So let's start with the most basic thing, and let's start with the definition of each. So arc is basically part of the circle. It is a curve, it is on the circle, and it is between 2 points on a circle. It's similar to the segment, so let's say this is AB, but unlike the segment which is a straight line, this is a curve on the circle itself. So this is for the arc. For the sector of a circle, this is on the picture on the right, it is part of the circle as an area between 2 radii and a arc. So it is an area between arc and 2 radii. So they have their own definition, they have their own thing. They are connected in a way. Basically, sector is defined using the arc itself. Radius is something that we can use for both of them. And what I have here prepared is something that you should also do in your textbook. You can make it definitely smaller. I just use this as an example because I'm going to draw extra stuff on the already prepared circle, half circle, and quarter of a circle. As an example, what I've also prepared here, you don't have to write this part down, is the circumference and the area of a circle. Why? Because I'm going to use these two formulas to determine what is the length of arc and area of the sector. Because I want to find these formulas for us to be able to use them in the tasks ahead, which are going to be from your textbook. So let's start from the full circle situation. Let's start from the full circle. The full circle is simple enough. Well, the arc is everything. It's the whole circle or whole circumference. So what I can write down in this here case is how would I be able to calculate the length of the arc is same as circumference. It's 2rp. This is it. For the sector area, well, the sector itself would be the whole circle in this here situation. Well, indeed, this means that the area would be r squared p, same as the circle itself. And one last thing that I'm not going to implement yet is going to be talk about the angle, more about it when I fill in the starting part for the arc and the sector. So let's continue on with the half circle. Now, half circle, what I've used here is like I've cut out from the starting circle half of it and then a quarter of it. So if I look at the half of it, what I can immediately say, considering its circumference, now I have only half of the circumference here. Well, half of circumference is 2rp over 2, which means we are only left with rp. Now this half of circumference is actually the length of arc too, because like I can say that this is going to be the beginning, I'm going to say this is going to be the end, and this is the half circle, this is the arc, the length of the arc. Continuing on with the sector, well, the sector is now from A to B, the upper, so to say, the upper part of the starting circle. And if I want to calculate its area, now its area should be half of the starting area or of the area of the full circle. So this is nothing more than r squared p over 2. Simple enough, hopefully for everyone. Now let's go into the third situation where I have cut out the quarter of a circle, the same starting circle. So in this here case, considering the arc, this would be the arc part. This would be the arc from A to B. Now, one thing that I want to mention now, and this is a good point for everyone, how do we name or how do we write down the arcs? So the thing is, as you can see so far, I'm naming from right to left, or so to say, anti-clockwise. It's always, this is the positive side in mathematics, and arc would be AB. Now watch out, there is also its counterpart arc from B to A. This is its counterpart. So this is whole thing from A, and its counterpart would be B to A. So watch out how you name the arcs. Watch out for that little situation. Okay, let me go back to the quarter of the circle. For the quarter of the circle, this means that I have quarter of the circumference, just the quarter, and this is the length of the arc. So quarter of 2 RP is going to be RP over 2. Hopefully you know how I got to this. For the sector, well, the sector is, again, since I already said it is quarter of a circle, the sector is going to also be quarter of the area of that circle, which means that this is going to be RP, R squared P over 4. Hopefully simple enough. Now, there is a reason why I put here the angle. There's going to be some connection with the angles in all of this. Let me show you. At the beginning, I'm just going to draw one radius. Let's say this radius here. I'm going to draw this guy, and I'm going to concentrate on let's say this is the horizontal segment. And if I look at the angle that I would make just using this here segment, well, the angle would be whole 360 degrees. So here is full 360 degrees. So I'm going to write down this is the angle of 360 degrees. Now, please, everyone, listen to this carefully. Try to remember this. Try to put it somewhere in your head, because next year at the beginning, we're going to go back to this here, and we're going to use it for something new, considering the angles themselves. And this is going to be introduction to whole another level of trigonometry, whole another level of looking at the angles themselves. And this is important step into getting to that point. Okay, let's go with the second situation. Now here in the middle should be the center of a circle, or semicircle, or quarter of the circle. And if I look at the angle in this here case, well, here is 180 degrees altogether, while in the third situation, this is the 90-degree angle. So let me write it down. So this is 180 and this is 90 degrees. Now, what is the connection between everything here? There is a connection. There is definite connection between all of this, and it goes like, let's look at the example with the 180 degrees. Let's look at the example of the area of sector. Now, first of all, instead of having 360 degrees, we now have 180 degrees. And there is connection between them. If I look at the whole picture, well, 180 degrees over 360, basically we've cut the angle in half. And what we have is 1 over 2. This is their ratio, so to say, if I want to look at that. Well, ladies and gentlemen, we have this 1 over 2 also here. Here we have actually, like, I could have written it down as 1 over 2 times r squared pi. I could have written it like that. Why not? Here is this 1 over 2, probably. Now, it also appears here. We have the starting equation, or starting formula, so, sorry, 2rp over, or times 1 over 2. Well, they will cancel each other out, and we're going to get rp. Aha, so there might be something more. Now, if I look at the 90 degrees, it's a quarter of 360 degrees. So I can also look at their ratio, and ratio is 90 degrees over 360, and it is the quarter that I've talked about earlier. This is the quarter. Definitely in this sector area, here is what we divide the whole area with the 4, or multiply with 1 over 4. And same thing for the arc length. Same thing here. 1 over 4 times 2rp is going to give us rp over 2. Now, just so you know, at the beginning, there is also the starting ratio, which I can look at. We don't usually talk about it, but it's useful in a sense. 360 degrees in a ratio with 360 degrees is in ratio 1 to 1, or basically just 1. And here is also this 1. I can have times 1, I can use times 1. Now, this is the starting picture. Hopefully, now you can see the connection that might be more or deeper than it looks at the beginning. Now let me show you one more example. Let me add, for example, if I want to cut the starting circle into six equal pieces. Let's say it looks like this. With the S, A, and B. And now what I'm going to do, I'm going to do all of these three things together. Now, way we can look at it, I can go back at the start and think it like I've thought I can talk about, or we can go through the same method as I did at the beginning with this purple stuff. We can go looking at this. If this is 1/6 of a full circle, this means that this arc is 1/6 of the circumference of the full circle, and which would lead us to RP over 3 in this here case. I can also look at the area sector in this here case, which is 1/6 of the whole area of a circle, which would mean r squared times p over 6 in this here case. Same thing for the angle. We, from 360, we went down to 1/6 of that, or actually 60 degrees. Which if I connect it with the ratio itself, so 60 degrees over 360 is 1/6. And this 1/6, I want to go backwards. If I want to start with 1/6, 1/6 times RP over R squared P is going to give us R squared P over 6. If I go with circumference 2RP times 1/6, we're going to end up with RP over 3. So there is definite connection between the ratio of angles where we put the angle that is actually in the arc or the part of the sector. Now here is 60 degrees. The ratio determines the length of arc and area of sector. So if you're given, so let me go with the last situation here. If you have angle alpha, whichever the measure of that angle is, whichever, center A and B, and you want to calculate the area of sector or length of the arc. Let's see what we're going to do. Each time I multiplied with the ratio, where alpha, so let's start with the arc. Let's start with the arc, the length of the arc. So let's start with that part. How are we going to name it? We usually name it with letter L, because in Croatian, arc is luk. So the arc length is nothing more than ratio of alpha over 360 degrees. This is this here ratio times what? Well, the starting circumference, 2RP. Now, of course, this is more complicated. Now we can simplify this formula, and I'm going to do exactly that. And the simplified formula is when I cancel 2 and 360, both with 2. So what we're left with is RP alpha over 180 degrees. This is the first formula, and this is the formula of length of arc. There we go. This is the first one. Now, same thing I can apply for the sector area. Now, unfortunately, this is a little mistake in your textbook, and this is a little common mistake in general. So let's say for sector, I'm going to use big letter A instead of letter P, just for the sense of the difference. So sector area is the same thing applies here. Alpha over 360 degrees, same ratio is used, but this time multiplied with R squared P. Or now I cannot simplify it. I can just reorder stuff to make it look prettier, so to say. And it is going to be R squared P times alpha. There we go. Now, as I've said at the beginning of today's lesson, considering the definition of a sector as a part of the circle between two radii and an arc, I've used arc to define sector. That's what I've done at the beginning. Now, what actually this here is applicable on is also on the formula of the area. If I look more closely into all of this, R, P, and alpha appear in both of these formulas. 180 also appears in 360. It's 2 times 180 gives us 360. So what I can do in the end, I can also write another formula for the sector area, and the formula is going to be RL over 2. RL over 2. This is another, so it comes from implementing the RP alpha over 180 into R squared P alpha over 360. And it leads us to this here formula. For state exam, you should be given the last formula, so you can use it. And this is pretty much it. This whole concept, this table that I've written down here, we could have continued on with 30 degrees, with 10 degrees. We could have gone down all the way to the 1 degree if we wanted to. But why is this concept that I talked about here important? Let me tell you one more time. Next year, at the beginning, we are going to go back into the whole here concept. And we're going to learn, we're going to have connection between the arc and the length of the arc and the angle. In the real life, it's simpler to measure stuff with a meter, for example, using the meters. And you have an actual measure. You can then measure it up whichever value you wanna get. But the idea is you can use the metric system to measure whatever you need, including the angles. And that's an important step. Including the angles, you are going to be able to measure the length, not the length, but the idea is you can find the measure of an angle using the length as a base, not any length. For example, meters, yards, whatever you want. Meaning, for example, there is a connection already. 2RP is 360 degrees. RP is 180 degrees. RP over 2 is 90 degrees, etc., etc. This is the length, this is the degree value of the angle. This is the length of the angle that we can look at. And this is going to lead us to a whole new measure with which we can represent the angles themselves. So watch out for this. This is an important concept and important part of the mathematics that we're going to use in the 3rd grade and then, of course, in the 4th grade too. Thanks, guys, and see you in the next video.